Okay, stretches and reflections. Remember that a transformation is a movement which affects the location and or shape of the quadratic. So, after doing the Desmo, as a summary, we should see that in the graph of y equals ax squared, the a value stretches or it could compress. So our base parabola could look like it's stretched, look a lot skinnier, or compressed, look a lot wider. Also, if it's a negative value, the negative causes our parabola to now open down or reflect. In/on the x-axis. So now we can put those together. So if the a value is less than 0, which again is a fancy way of saying a negative number, it causes the original graph to open down, which is a reflection. If a is larger than 0, it still opens up. Then we need to look at what the number is. If it is a number larger than 1, whether it's positive or negative, it's going to start to stretch all the points that way. If it is a fraction or a number between 0 and 1, whether it's positive or negative, it's going to cause the graph to start looking wider because every point is lower than it should be. If that doesn't make sense, let's just do a few examples and we'll see. So, we're going to look at our base parabola. Again, the more we do it, the better we are at quickly filling this out, and it is already filled out there. 0, 0, 1, 1, 2, 4. If we continued, 3 squared is 9, 3, 9, negative 3 squared is 9, 4 squared is 16, 5, 25, 6, 36, and it continues to go forever. If we're looking at our mapping notation, again, from vertex form, right now we have h is 0, so this parabola is shifting left or right, nothing. Our k value is 0, so it's not moving up or down. So we're just looking at the a value. And the a value here is 2. That a value affects the y, because no matter what x is, we do that first. So let's just think for a second. When x is negative 2, that is like saying negative 2 all squared, which is 4, and then times 2. Our order of operations, we do that first. 4 times 2 is 8. So if we think, how do we get from 4 to 8? And we're thinking about multiplying, we went times 2. Well, that makes sense. 1 times 2 is 2, but let's see. Negative 1 squared is 1 times 2. 1 times 2 is 2. Awesome. So this affects our y values. So the a actually affects our y in mapping notation. So how does it shift? We haven't moved to left or right. We haven't moved up or down, but we are multiplied by 2. So each y value is going to be multiplied by 2. 0 times 2, still 0. 1 times 2, 2. 4 times 2 is 8. And now I have my transformed parabola. So if I graph this, -2, 8, -1, 2, 0, 0, 1, 2, and 2, 8, I have y equals 2x squared. And it looks thinner or skinnier, narrower than my original y equals x squared. And that's because each point is twice as high as it originally would have been. If I think my first step was out 1, up 1, instead I'm going out 1, up 2. 1 times 2 is 2. So I'm looking at out 1, up 1, and I'm going in both directions from my vertex. My next step is out 1, up 3. Instead, and I'll use a different color here, I'm going 1 times 2, which is up 2. Now I should go up 3, even though I wrote 1 there, sorry. So out 1, up 3, but 3 times 2 is 6. 2 plus 6 is 8. So again, I can connect this to drawing. Out 1, I'm supposed to go up 1, but I'm going to go twice as high, so out 1, up 2. Next step is out 1, up 3, but 3 times 2 is 6, so out 1, up 6. Next one, out 1, up 5. 5 times 2 is 10, so that every step is going twice as high. So this is a vertical stretch because each point is being stretched compared to where it should be. If I use a different color just for my next one, I think the same thing. The x is going to remain the same, and the y is going to be half what it should be, or times a half. So 4 times a half, or 4 divided by 2, is 2. 1 times a half, or 1 divided by 2, 1 times 1 divided by 2, is a half. I might say 0.5, just so that I can see. 0 times a half is 0, 1 times a half is half, and 2 times a half, or 4 times a half is 2. And so now when I plot that one, -2, 2, -1, a half, 0, 0, 1, a half, and 2, 2, I start to see that that graph is a lot wider. If I continued, 3 squared is 9, 9 divided by 2 is 4.5, so 3, 4.5. Right, so I'm just taking my next step here and doing that one. 4 squared is 16. 16 is going to be 4, 8. So I'm just adding more points so that I can actually get a better curve to draw. So this purple one looks wider than the original. It's been compressed, so each point isn't as high as it's supposed to be, so it looks wider. In fact, each point is half as high as it would have been in the original starting parabola. So what part of the original ordered pair changed? It's the y value. Is multiplied by the a. If a is positive, it opens up. If a is negative, it opens down, connecting to what we already knew. Okay, let's look at a reflection. So right now, we have a -1. So our default parabola, which is already shown and drawn for us, is there. This mapping notation means it's going to affect the y. And right now it's going to be times -1. So 4 times -1, -4. 1 times -1, -1. 0 times -1, 0. 1 times negative 1, 4 times negative 1. So this entire thing still has the same curvature, but is reflected and now opens down. So negative 2, negative 4, negative 1, negative 1, 0, 0, 1, negative 1, and 2, 4. And if I continued, I would know that I need to go through 3, 9. So it would become 3, negative 9, and negative 3, negative 9. So reflection. It's like a mirror image. What part of the original ordered pair changed? Same thing. It's the y value. It is now a reflection. It now opens down. If we put that all together, we have our default equation. Now that negative 2 is still going to affect the y, so we map. Our x stays the same, and we're going to say negative 2 times each y value. So this is the work that I'm showing. What's my original? What does it become? I don't need to draw my original, but where's my original? Write it down. This point becomes that point, this point becomes that point, and I have 5 points to draw my graph. So 4 times negative 2 is negative 8. 1 times negative 2 is negative 2. 0 times anything, 0. 1 times negative 2, negative 2. And 4 times negative 2 is negative 8. Now, how is this original quadratic transformed? There's my points. I can draw it, and then I can state what happens. So I have negative 2, negative 8, negative 1, negative 2, 0, 0, 1, negative 2, and 2, negative 8. So it's a lot narrower because it looks, every point is twice as far as it should be, and instead of opening up, it opens down. So when I talk about now how is it transformed, it's reflected in the x-axis and has a stretch of 2. Reflected takes care of the negative, and the stretch of 2 talks about the a value.